working with operations with polynomials. So our first operation is going to be addition. We're working with combining like terms, so that is 4x squared plus 3x squared, and that gets us 7x squared. Negative 35x plus 2x are also like terms to each other, so that's why we're going to get negative 33x. Positive 49 and negative 5 combined because they have like terms, and that is positive 44. So, how do we know what kind of function this is? We know this is a quadratic function because it has a degree of 2. A degree of 2. And we see that right here, the degree of 2. This would have a degree of 1, so the way that we determine the degree is the greatest exponent value, which is 2 in this case. For subtracting, we're pretty much doing the same thing, except it's going to be a little different because we have to distribute this negative here. This has to be distributed to everything that's inside of these parentheses. So, I'm going to rewrite it out here so that it makes it easier. We have negative x cubed plus 0, that's supposed to be a 7, sorry, plus 0 because that's 7x squared, and then plus 7x and minus 4. So by combining like terms like we did with the addition, we get x cubed minus 7x squared plus 9x squared minus 16. And like before, how we determine what kind of function it is we look for the greatest value in the exponent. So our degree is 3. And it's a cubic function. When multiplying polynomials, one of the simplest methods to distribute all of the values in one of the parentheses to the other is by using something called the box method. So by using this method, we can put the two terms here, 5x minus 3, and then we could do 2x squared minus 5x plus 4, right? And so with this, we're just multiplying each to each other with the corresponding boxes. So 5x times 2x squared is going to be 10x raised to the third. Notice that you have the third because you're multiplying an x to another x, and you're using your exponent rules to add those exponents together. 2x squared times negative 3 is negative 6x squared. Negative 5x times negative 3, that's going to be positive 15x. Negative 5x times 5x, negative 25x. 5x times 4, 20x, and 4 times 3, negative 12. So, now that we have all of our values inside of our box,
negative 25x squared.
x squared. Yep, negative 25x squared. You're right. Thank you, Matthew. My good assistant over there. Negative 25x squared. So now that we have those values, we have to combine the like terms just like we did with the addition and the subtraction. Pretty much with every operation that you do, minus division because that's its own thing, you're going to be combining like terms. And so we have 10x to the third minus 25x squared plus 20, right? And so if you have these values on top, you can really just use these and put them right underneath. So you can do negative 6x squared plus, and that's an x, 15x minus 12. And then you add those together, combining like terms, and you get 10x to the third minus 31x squared plus 35x minus 12. And this is the final result. And you get, once again, a cubic function because our degree is 3. So I'm going to erase that really quick because we're going to be moving on to division. For division, the process is the same as long division for when you're dividing a whole number by another whole number, but it's different because you're also factoring throughout the process. We're going to do an example with a remainder and without a remainder. So first, we're going to work with a remainder. So x plus 2 goes into, well, we have to first think about what we can multiply x by to get x to the third. And that is going to have to be x to the second because of our exponent rules. So we're going to have x to the third. And then 2 times x to the second is going to be 2x squared. But we're subtracting, so we have opposite operations. So we're going to have 5x squared as our result because these cancel out, right? And so 5x squared, and we're going to pull this down and get 5x squared minus 6x. In order to get 5x squared with our x, we're going to do plus 5x. And then we're going to subtract 5x squared. And we're going to subtract 10x. So now we get negative 16x, right? And we're going to pull this down, and we got our negative 20. So, in order to get our x to equal negative 16x, we're going to do negative 16 because we have our x already, and because of opposite operations, we have positive 16x, positive 32. And our remainder is going to be 12. So, in order to do that with a multiplication statement, you would have to do x plus 2 times x squared plus 5x minus 16, and then you can add 12. And that is our multiplication statement. For without a remainder, we're doing the same process, but we know that we're going to end up with a remainder of 0. What do we multiply x by in order to get x to the third? X squared minus x to the third plus 5x squared. We get negative 8x squared plus 52x. And so what can we multiply x minus 5 to get negative 8x squared? We're going to multiply it by, obviously, negative 8x. So we have positive 8x squared minus 40, because we would have had a positive multiplying those together, 40x. And those cancel out, as these ones did as well. And then you're going to get a positive 12x minus 60. So, we'll get rid of that. Multiplying x by 12, we get negative 12x plus 60. And those both cancel out to equal 0. So that's our remainder 0. For our multiplication statement, we're doing something very similar to that one, where we're doing x minus 5 times x squared minus 8x plus 12. But because we added on the remainder here in this example, we don't have to add the 0 because it's not going to make a difference. The reason why we write multiplication statements is because what we're trying to say is if we do this, we're going to end up back with our original equation in standard form. Whereas this is sort of a simplified version
but it's not completely factored out yet.
So that is how you work with operations in polynomials.